Hello, this is Baris. Today we are going to talk about some important bash commands. Alright, let's start. So the first command is pwd. It shows us our current directory. So right now I'm in home Ubuntu, which is my home directory. Let's ls. ls means list. It lists the files in the current folder. Let's make a directory, another folder called dir2. We use mkdir command, and ls, you see we have now two different directory. Let's change directory to directory 2. We use cd, which means change directory, and again pwd. You see we are now in home Ubuntu and dir2. ls, you see there is no file here. Let's create a file. We use touch command to create an empty file. Touch and then a file name. You see we create file 1 txt. Here you see the owner is Ubuntu and the size is 0, and it is created on November 13. Let's create another file, touch file 2 txt and ls. Now you see two files, cd to the current directory, which means you don't change your directory. So that means your current directory. So if you cd to current directory, it doesn't do anything. pwd, you see we are still in home Ubuntu dir2. cd space 2 dot means our parent directory, which is home Ubuntu for us. pwd again, you see we are in home Ubuntu ls, and you see dir1 to dir2 folders. Let's change directory again to dir2 pwd. We are in home Ubuntu ls, we see our directories. Let's change directory to dir2, and let's make another folder under dir2, subfolder 1, and let's create an empty file under subfolder 1. So touch subfolder 1, file 3 txt. Let's go inside the sub, which there is no such directory. You see the error message, and this is our subfolder. Okay, we are in parent directory again, home Ubuntu ls. Let's find a file. So to find a file, we use find command. So find and then the search path. We put here dot, which means I'm gonna search this file in this folder. Remember, dot means this folder. 2 dot means parent folder. Find dot dash name and then file name. So I'm gonna search for file 3. So you see it is under dir2 and then subfolder and then file 3 txt. That dot at the beginning means starting from this folder. So this path is relative to our current path. Okay, let's go into dir2 again, and let's try to remove a file, rm file 2 txt. We use rm command to remove a file, ls, and you see file 2.txt is not exist anymore. Let's try to remove a folder, subfolder. You see we couldn't remove it because it says it's a directory. We know it's a directory. What is the problem with this? Because this subfolder has a file inside it. It's file 3.txt. So our remove should be recursive. It should remove everything inside that folder. So let's get help for rm. We use man command to get help for any command on shell command line. So let's say man rm. So it is manual for rm. It will bring this screen to you. You see all the options it explains, and we see -r recursive. So we can use this, and -f also force, it doesn't prompt any question. So rm-rf, which means recursive, and force subfolder. So let's remove this subfolder recursively. Yeah, it worked. ls, and we don't see subfolder anymore. Clean the screen. pwd, we are in dir 2. ls, we have only one file here, file1.txt. Let's copy a file. So a cp is a shorthand for copy. Copy source file and then destination file. So we copied file1.txt to file2.txt, ls, and you see file2.txt. And we can also do move. mv is a shorthand for move. So we move file2.txt to file3.txt. So with move, file2.txt should not exist anymore because we moved it. It is not copy. ls, you see there is no file2 and we have file3. Let's continue. And we have echo command to echo any string, any text to screen. So echo hello world, you see it prints hello world to our screen, but we can redirect this to a file also. So that greater than symbol, actually it's a redirection symbol. So we use output to file4.txt. You see we don't see any output on the screen because all the output went into file4.txt. And ls, you see file4.txt is there and its size is 13 byte. Let's cat that file. Cat means to show the file content, we use cat. And let's open this file with vi, which is an editor. It's a text editor like Notepad in Windows or a simple version of Word, but you cannot format your text here. It is just text. There is no formatting colors or fonts. So that's our content. Let's add a little bit more content. This is my first file, and escape right q. So to exit from vi, we first press escape and then colon and then wq, which means write and quit. ls, and you see now the size changed. It is 37 bytes. It was 13 bytes before. Let's clean the screen. pwd, we are in dir 2 still. We have these three files. Let's copy a log file to this folder. var log syslog is our system logs. You can see a lot of information in this about your system. Actually, let's cat it. You see there are too many lines. It doesn't fit on our screen, but there is another command to page the output. Now you see output page by page. So this is first page, and then when you press on space, you can go to next pages. So in that way you can review your output. And we have that head command. It gives us first 10 lines, and actually I can specify a number of lines with n. So this is first 5 lines in logs.txt. We also have tail. It gives us last 10 lines, and again we can specify the number of lines. We can grep something inside log.txt. Grep means search a pattern inside that file. So we are searching for errors in the logs. So you see we have 2 error lines. On the screen you see red because grep highlights the findings. Clean the screen. pwd, we are still in dir 2 ls, and we have these files. We have logs.txt. Now let's do word count. wc is a shorthand for word count. We can count number of lines in this file. So we have 105 lines in logs.txt. We can also count characters, which wc and then -c logs.txt. So we have 10,000 characters in this file. So L for line, C for characters. All right, let's cancel this. On command line, you can press on Control C to break the current command. Let's clear the screen. Get this log.txt and then grep errors, and then let's count these errors. Word count -l. So we have 2 error lines. Actually, if you remove wc, you see we have 2 error lines, which the output is correct. We can also use sed. Sed is a string editor. It can replace, substitute any string from input. So here actually that pipe connects comments to each other. Like cat logs prints the content, right? And that output goes into grep as input, which it search for error, and grep's output goes into sed as an input. So there is a chain of comments here. Every comment gives input to next comment in the chain. So as said, it has many use cases. You can search for it online. S for substitute, G at the end is for globally. So it will substitute all the findings. If you don't specify G, it will substitute only one. So let's run this. You see here errors are capital letter now. Actually, let's do grep error also to highlight findings. See, it's capital. So sed is to process string outputs. Let's open a new file with vi editor, file 5.txt. Press I to insert any text. Let's add some names here. Alice, a few times, and then Bob 3 times. And write Q, exit, and cat this file. That's our file 5.txt. Let's count the words. See, we have 5 lines here. Now what I'm gonna do, I'll cat this file, and then I'll use uniq, which means remove the duplicated lines. So see, we have only Alice and Bob once. It removed the duplicated lines. So we can edit this, and let's add more stuff here, like zebra, maybe Jack, write Q, cat this file. So this is our new file. We can do also this, cat this file and then sort it by the names. So you see it is sorted. And we can also add -u to make it unique. So we sorted it and we removed duplicated lines. If you look at the manual, you can see -r for reverse, so we can sort it in the reverse order. See, it starts with zebra and ends with Alice. All right, that's cool. Let's clean the screen again. pwd. We are in dir 2 still. We have these files. Let's go to our parent folder, which is our home directory, and I'm creating this script.sh. So this is a basic shell script. I'm gonna just put hello world here. Right, Q, and then exit. So let's try to run this. So script1.sh doesn't work because remember from the previous video we said when we run a command on bash, it first check $path variable. So current directory is not in the path variable. So what we need to do, we should add // because that means this folder. So we have to specify this folder. It still doesn't work, but the error changed, right? It is permission denied. So if you run ls-l, you see the permission. So it has read and write access, but it doesn't have X, which means executable access permission. So we have to add X. So R for read, W for write, and X for execute. So let's add that permission to this script. We use chmod command and then +X, which means I'm adding this permission to this script. Now you see it has X permission, which is now it is executable. Let's run again. You see it prints hello world, and let's check the content. Yeah, this was our content. Let's remove read access. So chmod -r script1.sh, you see the permissions, there is no read access, and that means when we cat it, we cannot read it. So it says permission denied because there is no read access. So let's add it back. chmod +r and then script1.sh ls, and you see we have read access again. We can use also numbers instead of letters. So when you say -r, it gives permission to everybody. You see on the output there are 3R or 3X. The first one is for myself, second one is for my group, the third one is for everyone else. So with numbers we can specify a number for each group. So 400 means for myself, 0 for my group, and 0 for others. So you are gonna ask what is 4? 4 means read actually. So 1 means X, 2 means write, 4 means read. So you see we only gave ourselves read permission. So there is another command, whoami. Whoami shows you who is the current user. So the user is the same user on that file. So it is Ubuntu. I can add another user. We use useradd command to add another user. But as a normal user, I cannot do it. I get permission denied error, so I have to use sudo. Sudo means do things with super user rights. But to do this, you have to configure sudo. Currently, Ubuntu is configured, which means it can use sudo. Not all users can use it. You have to configure these users. As Ubuntu user, I am adding another user with sudo. It worked. pwd, I'm in the home. Where am I? I'm Ubuntu. So I can use SU. This is a shorthand for super user. So I want to switch to super user, but actually I don't remember the password, so this is gonna fail. Authentication failure. But I can use sudo su dash also. So I have that right as Ubuntu user. See, whoami shows root, not Ubuntu anymore. So now I'm root, which is the super user. So let's edit another script, script2sh. I'll create a while loop which loops forever and sleeps 5 seconds each time. Actually, let's echo also something to see the progress. Right, Q. Let's give X permission to run it, execute it, and then ./script2. Now you see it echo, it prints hello every 5 seconds. So this is gonna last forever, but I use Ctrl-Z to break that, but actually it is still there. It is not completely broken, so it stays in the background. So BG is a shorthand for background. We throw it to background. You see hellos on my screen. It is still running in the background actually. And there is another command called jobs. It shows us what is in the background. See, it is still working, and we can use FG, which means foreground, to pick it from the background and interact with the command again. So let's remove that echo because it distracts our screen, and run it again. So it is running in the background again. So I broke it with Ctrl-C, and I also can use this ampersand, the and symbol, to send it to background. You see jobs output, it is in the background, and I bring it to the foreground again with FG. Let's PS. PS means process show. So this command shows us what processes we have. These are our processes. If we want to see all the processes in the system, we have to use PS AUX, or there are other options also, but this is the most common use. It shows us all the processes. So how do we install something on any Linux machine? So this is Ubuntu. In Ubuntu we use apt, apt install, and then package name. I'm installing Redis, for example, here. On another system, it can be different. Like on CentOS, we use yum, Y-U-M, yum install, and then Redis. After you install anything, if it is a daemon, daemon is a special term. It means a process runs at the background forever. So like database, Redis is a database actually. So we want our database to be accessible all the time, right? We don't want to stop it. When we run ls, it starts, it shows the output, then it ends, right? It doesn't last there forever. But we want our database or web server to stay there forever, right? So that kind of services, we use systemctl command to control these services. For example, systemctl status and then Redis. This gives us status of Redis. It is active and running, so that means the service is up and running. We can stop it actually. Systemctl stop Redis. You see now it is inactive, and let's start it again. and check the status. So it is running again. Yeah, that's how we control system services. We can see this service actually with ps command. You see ps aux, and then let's grab Redis. So you see Redis in our process list. Yeah, and then let's stop it, and then you see we don't see Redis on the output. Let's start it back again and grep. You see it is in the process list. So who am I? I'm a root. I'm in the root folder, and with exit I exit from a session. Since we came here from Ubuntu, when we exit we go back to Ubuntu. But if I exit from Ubuntu, I lose the connection because there is no other session to go back. So I'm in home Ubuntu. This is our home folder. Let's run cat. Actually, cat requires, remember, a file name, right, as an input. But since we don't specify a file name, we have to provide a file name. It is waiting for that purpose. And I break it with Control Z. You see it is in the background. If we run ps, we should see that because it is still waiting at the background. Yeah, you see cat command, it has that process ID 5342. And now let's kill that process. To kill process, we use kill command. Kill, and then signal number, and then process ID. You can check the signal numbers, but 9 is to kill a process. We can send other signals to a process. Some of them kill, some of them doesn't kill. Now let's grep. As you see, there is no cat. And the other command I want to show you is top command. It sorts them by their system resource consumption. So when we have performance problems, we usually use top command. You see that load average here. It shows us what is the load. I'll explain this later. It shows us CPU usage and memory usage. So it's very handful tool. We also have free command to see our memory usage. If you run free, you will see it in bytes. If you run dash h, you will see it human readable. Yeah, we have 1 gig total memory, and 200 megabyte is used. df shows us file system usage. You see our root file system. It has 8 gigabyte, and we use 3 gigabytes of it. We can use df with dash h also. Dash h means human readable. You see numbers more human readable. ls, yeah, we are here, and du is disk usage. So df is for file systems. So when you have different disks or partitions, you see them with df. You don't see folder per folder usage with df command. To see that, we use du, which is a shorthand for disk usage, and it also has dash h. Our current folder and all the folders inside it recursive